Hello, everyone. This is Aravind Nalan. I'm the services lead, West and Central US here at Yugabyte. I started my distributed database journey with NoSQL, first as a trainer, teaching Cassandra to some of DataStax's customers for about 2 years, and then as a solution architect, implementing Cassandra for about 4 years. I'll talk a bit about what brought me to Yugabyte in a minute. But first, let me introduce my co-presenter for this talk that I'm thrilled to have join us. I have the great pleasure of welcoming Kannan Ramamurthy. He's a senior manager, strategic incubation office at General Motors. I worked very closely with Kannan and his team of engineers as part of the joint Yugabyte and GM team that just migrated a large application called Vehicle Data Factory, or VDF for short, from Apache Cassandra to Yugabyte. Kannan, could you please introduce yourself?
Yeah, first of all, thank you very much, Aravind. Yeah, my name is Kannan Ramamurthy, and I'm a senior manager in the strategic incubation office here at GM. I've been with GM for 15 years. And my team works on what I would call as beyond the horizon initiatives here at GM. We incubate and productionize technologies that solve problems in the connected vehicle, big data, fast data, and autonomous vehicle domains. For example, my team introduced Apache Cassandra as the NoSQL cache for all of GM's connected vehicle data, processing some of the largest transaction volumes anywhere in the automotive industry. We also introduced Apache Pulsar as a streaming data egress solution for egress of data to external partners. We have been really successful in running Cassandra for 5 years using a continuously available architecture. And then, over time, as needs changed, we wanted to start looking at other products, and Yugabyte was one of the key platforms that my team evaluated. With that said, Aravind, really nice talking to you this afternoon.
Thanks, Kannan. Before jumping into the details of our joint project, let me help set that up a little bit with a quick story on my background and what brought me to Yugabyte. I'm assuming most of you have a sense for who Yugabyte is at that point, so I will skip over the product overview and the company overview. You will get a lot of that in other sessions that we're going to have. As I mentioned, I started my database career with NoSQL, from training organizations on it to being a solutions architect. Towards the end of my time at DataStax as a solution architect, I started realizing that NoSQL databases like Cassandra helped us figure out scalability and high availability, how to do large-scale databases that are highly available and fault-tolerant. But there's obviously going to be some trade-offs to figuring all that out, right? So they imposed a huge amount of penalty on the developers, not just the developers, but in terms of data modeling as well, right? You had to give up a lot. SQL has been their lingua franca for a long time, and they would not give it up very easily, right? We talk about some of these database trade-offs. SQL and NoSQL both have their unique benefits, but in choosing one over the other, you end up giving up the benefits that the other has to offer. It essentially starts becoming a no-win situation for developers, right? This led me to Yugabyte, where if you look at the vision of our founders, the vision is to eliminate completely these trade-offs. We are starting to chip away at most of those trade-offs, but the goal is to eliminate them completely and bring together the best of SQL and NoSQL, along with the core concepts of open source, cloud native, and multi-cloud. Yugabyte offers multiple APIs in a single, scalable, fault-tolerant, and highly available database. It supports a YSQL API, which is inspired by Apache Cassandra's CQL, and a YSQL API, which is compatible with Postgres. In fact, we use the top half of Postgres within our solution. Now, in the era of edge computing and the amount of data that it generates, we need a database that can scale as the data grows, can handle the velocity at which the data is coming into a database, into an application, into a database that can be deployed globally, closer to where the devices are, so that you can handle the kind of performance requirements that you have for these applications. A database which can support high node density, thus giving us a low total cost of ownership, right? So it is for many of these reasons that I think we got on GM's radar as they started thinking about modernizing their data layer that powers one of their key applications, the vehicle data factory. Kannan, thanks again for joining us today, and let's jump right in. Let's start with giving the audience a better sense for this key GM application, VDF. What role it plays for GM, how mission critical it is. I know we talked a lot about the kind of scale and the growth plans that you have for this application.
Certainly, yeah. VDF is the application that ingests and processes the connected vehicle data that I mentioned earlier. This data is used to support our mobile apps like the GM My Brand apps. The My Brand apps were formerly known as OnStar mobile app, which will let you perform vehicle services such as remote start and display vehicle health, so to speak, right? So the connected vehicle data is also used in a plethora of use cases, ranging from usage and driver-based insurance to data monetization to vehicle diagnostics. This data is also collected from millions of connected vehicles at various frequencies, right? So not only is the data set big and large, but it's also fast. And with every new model year that GM started introducing, right, we increased the amount of data and the frequency of data that we could collect, opening up the possibility for newer use cases and disrupting existing ones. So, for example, we can today collect data for from vehicles about potholes and road conditions and so on for vehicle customer consumption of road safety, right? That's an example. That's a newer example. So just imagine the vehicle to vehicle, the vehicle to infrastructure, or the vehicle to grid for EVs. These are all new possibilities that can happen with all this connected vehicle data that we can collect. And especially, with the onset of 5G, you can only imagine, the interaction that vehicles can actually have with the infrastructure, also known as, V2X. And that can open up a lot of different possibilities. So while Cassandra worked really well from an availability standpoint, we really wanted to look at what we could do to innovate further. As I had mentioned, not only to address performance issues. So one example of a performance issue is with respect to node additions, right? It used to take us a week to add a node, and to do that in production, where we have to have a change control open for such a long time, was not ideal at all, right? So while the application was ingesting more and more data at a faster rate, we simply were not able to keep up with the compute and storage demands. And because the writes per second increased, this really started affecting the reads as well, right? Remember that the VDF application APIs, um, they actually provide the APIs for the My Brand apps, as well as for all the data that we egress out to our partners. We absolutely cannot miss the SLAs in any of these scenarios. The other thing that I noticed, actually my whole team noticed, was that the open source contributions to Cassandra started to trickle down, and we were not sure whether we would be able to keep up with the pace of innovation. And so that prompted us to start looking at other options, especially even from a vehicle platform standpoint. We started to look at software defined vehicles and autonomous vehicles platforms and so on, right? So really, one thing we did was we looked at Yugabyte, And kind of a funny story here, the Yugabyte team, the founders, mainly, they presented the Yugabyte product to us about 4 years back. And while it seemed quite promising, we were not sure if, we wanted to assume the risk of working with a startup like that, right? But in 2020, as we started approaching the time for tech refresh, because not only was the Cassandra operating system was old, the hardware was also old. We really wanted to see what Yugabyte offered, and that's where we started this journey with Yugabyte.
Okay. So with those, with a couple of challenges that you mentioned, which I'm sure many of the people who are listening to this talk, they can relate to these seeing these kinds of problems in their own applications and databases that they might be using. I know you set out to examine and find a newer solution that could eliminate some of these challenges. For your specific use case, though, what were the critical capabilities that you needed a database to provide? Can you talk a little bit about the evaluation that you did and the POC that you did with us, with Yugabyte?
Certainly. So, when we started looking at Yugabyte, one of the things that we wanted to do was definitely to perform a POC and compare the performance of the database, vis-a-vis Cassandra. So we wanted to, compare that against Cassandra. And also we wanted to kind of see the performance of the database on both Intel and AMD platforms. As we process a heck a lot of data at a really fast pace. So even in the POC, we actually really pumped up the data volumes to see how well the database platform would perform. And after the impressive POC results, we really recommended that we seriously consider using Yugabyte as a replacement for Cassandra. And that's when we really started this journey. And some of the key requirements that we wanted in the new platform were, of course, performance, continuous availability. Remember that vehicles send data all the time. It's not like I have the luxury of a downtime whatsoever for planned or unplanned activities. Vehicles, people drive all the time, right? So we get the data all the time. Ability to add capacity quickly, and in some cases, a better data consistency model is also important. To give you an example, right, the data that we collect from connected vehicles is always collected per customer consent, right? The customer actually has to say yes in order for us to actually collect the data. Otherwise, we have to discard. Now, if you don't have that consent data available to us in a consistent fashion, and at the time when the data is being received, what will end up happening is we'll end up collecting data, which we'll have to go through a painful process to actually get rid of it after the fact. You know how difficult it is to purge data in NoSQL databases, right? So those are some of the key areas that we tested the platform for, and we really like what we saw.
Yeah, I was going to say, when you are talking about vehicles continuously sending data, you cannot afford a stop the world pause. Just because you're doing a database maintenance or something like that, you cannot really afford that. So with those needs in mind and the evaluation that you did with Yugabyte, we all realize, of course, that since you're here talking with us, that you chose Yugabyte as a key database for this application. In just a few sentences, can you summarize what the main capabilities that YugabyteDB delivered versus other options that you considered, and what made the team lock in on this particular?
Yeah. So, like I said, Yugabyte definitely improved on the data consistency model versus Cassandra. We were able to add nodes. Like remember I said when we were running with on Cassandra, the node additions took almost up to a week or maybe even 10 days, depending upon what happened. And one of the problems that you would have is if you run into a month-end scenario where you would basically in GM you would have these change freezes. So sometimes we actually have to start adding these nodes, hoping that we don't run into a month-end freeze, because that will really put us in a bind, right? So Yugabyte really, when we did the POC, as well as when we started doing the performance testing on real data, we were able to start adding nodes in less than a day, which meant that we could easily add capacity for both compute and storage, pretty immediately. Availability was another huge thing, and of course, performance. And to give you a little glimpse into what I mean by performance, maybe I can give you some statistics
Definitely.
on that, right? So, after performing, extensive testing, right, one of the things that we did was, um, during this whole process, we really started testing the heck out of the product, stretching it to the edge. And while we were able to meet all the performance SLAs, the original SLA that we had in order for us to load the data from the legacy Cassandra databases to Yugabyte was, something like loading a day's worth of data in about 8 hours. And actually, after a lot of testing and thanks to the wonderful support from the Yugabyte team and you specifically, Arvind, we were able to tune it down to loading data, a day's worth of data in less than 3 hours, right? And we're talking, millions of transactions per second and so on, right? So that, that in itself, and also when we were going through the testing process, we uncovered all kinds of edge cases that could happen. And for each edge case, the Yugabyte teams, the support, team basically came back and gave us the appropriate amount of support to ensure that we were successful in, doing the data migration from the old platform to the new platform.
Yep. So you liked what you saw during the POC we did with you, and then chose to go with Yugabyte. Talk a little bit about the migration requirements you had for, I think you touched on it a little bit, but talk a little bit more about the migration requirements you had for us.
Right. So, like I said, from a migration standpoint, really, we had to load a large volume of data. So one of the things that we did was in our architecture, we have data in Cassandra, but also for some of the what I would call vehicle telemetry, the large tables, we have a copy of that in our big data ecosystem also. So one of the things that we had to do was to basically take that data and preload it into Yugabyte. And like I said, our SLA was to load a day's worth of data in about 8 hours so that we can actually catch up and have the application run in parallel and do the cutover. But thanks to the tuning opportunities that we could get from Yugabyte, both from your team, Arvind, and also the optimizations that we did from a data model standpoint, to actually improve the performance, we were able to load that in 3 hours, and we're talking like maybe at the rate of maybe 3 million messages per second, right? So it was a huge improvement when it came to how quickly we were able to process the data.
Yep. So I think if I remember correctly, when we started out, we were getting about 650,000 TPS writes per second, pretty easily without doing too much work. That itself was pretty good. You could load 2 days worth of data in like 16 hours or something like that. But then I think one of the key challenges that we ran into was a space amplification issue compared to Cassandra. How much space that table would take in Yugabyte. And once we figured out how to fix that using a bit of a data modeling modification, that actually, we not only mitigated the space amplification issue, but the performance just went through the roof, right? I think immediately we started hitting like 2 million writes per second. And then I think your team saw that, and they were like, oh, we are at 2 million writes per second at 40-50% CPU. Can we hit 4 million at this rate? So we ended up hitting like 3 million, as you said, without consuming too many resources as well.
Yeah, and you have to remember that we always like to keep a certain amount of CPU buffer anyway, right? So
Yep.
even in production, right, when we were doing the migration, we didn't want to go full throttles, but so the 3 million, that you just talked about was a good sweet spot for us, right?
Yep.
And also, on the read side, also it was very
Yeah.
similar in terms of the performance, right? So we were able to read much faster than what we had ever seen with Cassandra, right? That was a huge surprise
Yep.
for the whole application team, and it really boiled down to the effort that both my team and the Yugabyte team put together to ensure that this was pretty successful.
Yep. 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 Definitely. Kannan, talk a little bit about, we talked a little bit about the migration performance and what we saw during the migration, but talk a little bit about the application performance improvements from the application perspective, what you saw there.
Oh, absolutely. So, like I said, with every new model year, we basically increase the amount of data that we collect and the frequency with which we collect the data, right? Basically, what happens is with every new model year, we have the capability to look at different aspects of data that you can collect from a vehicle standpoint, whether it's coming from the vehicle sensors or with the vehicle cameras and whatnot, right? So the as the frequency increased, like I said in Cassandra, one of the things that we did was, the messages always often used to queue up, because Cassandra was simply not able to process at the rate at which the data was coming in. So the application team had to do a lot of what I would call application gimmickry to throttle down the rate of ingest so that we can not overwhelm Cassandra. But when we introduced Yugabyte, that just went away, right? We saw a 10x improvement in processing from an application standpoint. So for all the Spark micro batches that take place for processing some of the data, it was really what was taking like a minute or so was processing in less than 10 seconds in some cases, and in some cases really it was like a 10x improvement.
Yep. Yep. Could you talk a little bit about the support you received from Yugabyte during this process, and how would you rate the partnership between Yugabyte and
Yeah,
GM?
certainly. I mean, obviously, first of all, I have to thank you, Arvind, personally for being there throughout the project
It
and
was a
helping
pleasure.
my team really, and the database team help tune the product and also help us, from a data migration standpoint, and helping us with the cutover strategy and so on, right? That was, without any reservation whatsoever, I would have to say that that was a huge help. And then from a support standpoint, one of the things that we did was, as and when we discovered issues, and the issues that, mind you, are the kinds that you would only find when you have this much volume of data, or the rate at which it was processing, right? So you're not going to find that easily, when you're doing normal testing, right? So and the database teams would basically open up a support ticket, assign it appropriate priorities, and immediately we would get back some kind of a resolution from the Yugabyte support team, right? Even when you were not around, because testing was happening round the clock and people were loading data round the clock in order for us to meet the deadlines. And that was one of the key aspects that I would like to highlight, is to basically acknowledge the fact that this support was essential for us to actually succeed. My team ran Cassandra. We were running it on our own. We didn't have any vendor support or anything like that. We were pretty successful, but when we were actually going from what we were used to something this large, specifically since the changes that were taking place in the automotive industry, specifically with software defined vehicles and with AVs and EV and so on. This was really essential that we had introduced a strategic platform like this.
Awesome. Awesome. So before we wrap up today, Kannan, one final question to help summarize your experiences and what we have talked about today. As you look back on your journey, and hopefully this is just the beginning of a long journey together, what stands out to you as the biggest takeaway that may help anyone listening that may be in a similar situation?
Yeah, I would say that this was a very challenging project because failure truly was not an option for us. Not only were we pleased with Yugabyte, DB and the support team and the extended team, but even more so with the level of collaboration between GM and Yugabyte, right? That was really important for us to actually, become successful in migrating one of the largest applications here at GM from Cassandra to Yugabyte. But that said, the journey has only begun. We have a lot more that we have to do with Yugabyte.
Thank you again, Kannan, for taking time from your busy schedule to talk with us today. It's been a pleasure as always, and I'm sure these valuable insights have been helpful to all those watching. Thank you.
Thank you, Arvind. Thank you very much for inviting me.